config ETH3 down. Hi, and welcome back to our Check Point ClusterXL series. In this video, we are getting into an important part of our cluster setup, which is the supported topologies for the synchronization network. And with that, I mean using bond interfaces for sync traffic. And let's start by, so here we have our first gateway and the second gateway. So we need to do this lab. We need two new interfaces here to this switch. Let's activate them. So ETH3 to gig 11 and ETH4 to gig 12. So we know 11 and 12, 3, and we do the same for the other side here. So 3 to 13. So we need 3 and 4. Let's do the same here. We don't have enough, so let's add some interfaces here. It's only 4, let's make them 6 for example. Okay, add the same here. So 8, make it 10. Okay. Now and add. So we have the ETH3 and 4 here, this side, and ETH3 and 4 this side. These will be used for the sync traffic. But before we get into some topologies, let's answer a common question. Why might a single 1 gig sync port not be enough? So here, if we take a look at this gateway, this is the 6900. And if we look here on the sync, this is the sync interface. And if we look here, we see that it is only 1 gig. So no more than 1 gig. Why might a single 1 gig sync port not be enough? It is because of maybe high traffic volume, large state tables, frequent state changes, and redundancy and future proofing. I mean planning for future growth. So why use a bond of 2 physical interfaces instead of the sync interface? So using a bond of 2 physical interfaces instead of a single sync interface in Check Point cluster can provide several advantages. So redundancy, increased bandwidth, load balancing, improved reliability. So overall, using a bond of 2 physical interfaces for synchronization can enhance the performance, reliability, and resilience of the cluster setup, making it a preferred choice in many enterprise environments. So now let's run our gateways to start creating our bond interfaces. So let's go to our topology here. Let's run these machines to be able to log into the Gaia interface and create our bond interfaces. Now our gateways are done starting, so let's log in them and start. So let's log in here and we log in there. So here in this gateway, we go to network interfaces and we'll do the same there. So network interfaces, and here we click on, let's open the lock, yes, and we create a new bond interface. So here we need to add what physical interfaces should be included in the bond, and as we have seen here, it is 3 and 4 on both sides. So let's do that. So 3 add and 4 add. and we need to choose active backup. So bond operation mode, so when creating the bond, specifically for sync, what operation mode should be chosen? And it is the this one, the active backup. When creating a bond specifically for synchronization in a checkpoint cluster, the recommended operation mode is active backup. This mode provides redundancy, ensuring that if one interface fails, so if ETH3 or ETH4 fails, the other can take over without interruption. So key points for active backup mode. So it is redundancy. Only one interface is active at a time. So we have two interfaces, two physical interfaces, but only one is used, while the other serves as a backup. This ensures continuous operation in case of a failure. You should not explicitly configure the primary subordinate interface in ClusterXL when setting up the sync interface on a bonding group for redundancy. So let's give the bond, and here we need to give the bond interface IP address. So let's take, for example, I don't know, 60. This one is 3, so it's 3, and something like that. Let's call that sync bond. And what we have here, so here we don't have any settings, so let's click OK here. Let's go to the next one. We do the same here. Let's open the lock. Let's create a bond interface. Same, we take 3 and 4. Sync bond. It is important, this number is important only on the same gateway. Choose active backup. IP address is 62. So 255.255.255.0. Okay. So now we need to create an EtherChannel on the switch or port channel. So let's open that. Switch here. Configure mode, config mode. So we have 3 and 4, and 3 and 4 are connected to 1, 1 and 1, 2. So let's take interface, a range of interfaces, take a bit, 1, 1 and 1, 2, something like that. And we can say channel group. Let's call it 10 here, and the mode should be on in this case, something like that. So now we have created EtherChannel, and now we can see it is going up. So if we do show IP interface brief, now we have a port channel which is up. And now we need to make the same but for the other side. So we have 3 and 4. So let's exit here. We can not make a range here, so we can take every interface on its own. So interface giga 2.0, so channel group. Here we need to choose another number, so it should not be 10. So let's take 11 here, mode on, and we exit and do the same for the other interface, which is 1 divided by 3. Channel group 11 mode on. Let's save here. So now we have a bond interface here. We have ether channel here, or port channel here. We have bond here, and we have our port channel here. So now let's run Smart Console to import these changes. So in the switch, ensure that the switch ports connected to the bonded interface are configured to support bonding, but do not require LACP or other dynamic link aggregation protocols. So the mode on Cisco switch, this setup allows the two interfaces to be aggregated into a single logical link, providing increased bandwidth and redundancy. The on mode ensures that the switch treats the two interfaces as part of the same ether channel without using any negotiation protocol like LACP. This configuration is necessary to ensure proper link aggregation and to prevent potential network issues. So let's look at this one is working. Okay, let's try again here. So here we go to our cluster object, double click, network management, and here we need to click here and get interface without topology. So here we see we have got these two interfaces, new interfaces, but we can't have two sync interfaces, so we need to change this interface. So before we had this link here as for sync traffic, but we can't have two interfaces for sync, so we can't configure sync here and sync there. So we need to change this to a normal, so from sync to check cluster, and give it an IP. So here we have 1211. Let's take 13. So 10.1.1.3 and 24. Click OK. And now we can change this to sync. And we can take this override list inside network and activate anti-spoofing. Okay. Okay. So now we have this bond interface, bond 20, as for sync, and we have this interface and this interface on different gateways. So let's click OK here and install the policy. Install policy. So now, as we can see here, our policy is done installing. So let's go to our topology here and let's use Wireshark to check the traffic on the interface ETH3. So let's capture and open this. So as we can see here, it is sync traffic. Sync, 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 as we can see. Let's check the other side here. Interface 3. Let's check that. The same, sync, 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 sync all. At the same time, we can check the other interfaces. So here we can check interface 4, which should not show any traffic because it is just a backup interface. So as you can see here, no traffic on that interface. The same is true on the other side. So capture and no traffic. So how to test a failover? So we can, for example, here we can choose to shut down the interface 3, for example. So set cluster interface ETH3 state off. something like that. And we can't, because cannot execute this command to acquire the lock. Okay, let's acquire the lock. I'll try again. So ETH is a member of a bonding group, so we can't shut it down this way, but we can go to expert mode. I'll try if config ETH3 down. I think this should work, something like that. And we can check again. And now let's check ETH4 and see what traffic is going there. As you can see now, ETH4 is the sync interface. So we have two different interfaces on the same bond. If this one, first one, ETH3 is down, the next one is enabled. So let's shut down this, and here, let's see which interface is answering. I think it's still 3 here. Yes, it's still 3. So now, listen, this topology is not the best one, because we are connecting two gateways on the same switch here. So in production, you should have 2 switches, because this topology is not redundant. If this switch is failed, so everything is down. And when we have 2 switches, we can connect ETH3 to one and another switch, the ETH4 to the next switch, and here the same. And we don't need EtherChannel on the switches, so it is not. It's just a very simple connection. So we add something like that. Let's add a switch here. Yes, save. For example, we add this switch here. We connect ETH4 here and ETH4 here. And if one of them fails, and the other one should continue to work. For now, we can connect this gateway ETH4 here and this gateway ETH4 here, and then we don't need any EtherChannel here, and everything is still the same. Why that way? We have a redundant topology. So if this switch fails, we have another switch. If this one fails, we have the other one. So this video is done here. Thank you for watching, and see you in the next video.